Hi, I'm here to do and explain the iodine clock reaction lab. You need to understand what an iodine clock reaction is because what we're going to do is we're going to manipulate three different variables. We're going to manipulate the concentration of different reactants, the temperature, and the use of a catalyst to see how that affects the rate. So we're going to be taking times for how long the reaction takes. So what I made was three different solutions. So solution A, I dissolved potassium iodide in water. And what we care about is the fact that we get iodine ions in there. So I-1 ions. Solution B, I took sodium thiosulfate and it produced these two, but this is the ion we care about, the S2O3 - 2. And I added a little bit of starch solution to B. And it doesn't do anything initially with B. And then when I made solution C, what we care about is the S2O8 - 2 ion. So you can see kind of I've color coded them. So what we're gonna do is we're always gonna start with, in a beaker, solution B. So I'm gonna put B in first. And then I'm gonna add A and C at the same time. And this is what's gonna happen. So what we have here, get a little closer. What we have here is we have the iodine from part A. That's going to react with the S2O8 - 2 from part C. When these two react, you get some sulfate ions, but more importantly, you get iodine, I2. So iodine will react, and maybe you've done this in bio, where you do like a starch test to see, or use iodine, for a starch test to see if starch is present in something. But iodine will react with starch. And when these two react, right, because that was in B, so if I had A and C to B, right, without the starch in it, you're going to get kind of a blue-black solution. Okay, so this changes color, but it's not done. This reaction keeps going. So this part happens, and then the iodine is in another reaction, a second reaction, with the S2O3 from part B. So when these two react, it turns back into iodine ions. So when this happens, this is colorless again. Okay? So, and then this goes back and reacts with more of the S2O8. So it's called a clock reaction because it just keeps cycling through. So these two react, making this, which is this blue-black, but immediately that'll react with this and go back to colorless. And then this will go back here. So this is just going to keep happening, and you actually won't see the blue-black color until we run out of this. When we run out of B, the reaction stops right here. So this won't keep going. We won't go back to the I-. We'll stay with the I2, and it will be a blue-black color, and it'll just stay there. You won't see it until this runs out. So that's what we're going to do is we're going to time. We're going to see how long it takes for this to run out, and we'll know that when it turns blue. So you're going to have a stopwatch. You're going to need a stopwatch like your phone would be perfect. And you're going to start it when I tell you to start it, when I add A and C. And you're going to stop your stopwatch as soon as you see the first hint of blue-black. And you will notice a color change. It is very distinct. Okay, so let me get this set up. All right, so I'm going to do this in front of a white background. Excuse me. It'll be easier to see the color change. All right, so I've got my beaker here to start. I'll do it this way. All right, and I'm going to first add B. So B is the thiosulfate and the starch solution. So I'm adding 10 milliliters to this to start. Okay, I'm going to move this to the side. All right, so we're going to do this with different concentrations. The first one is kind of our standard solution. So we've got 10 of B, and then I'm going to add 20 of A. And get set up, and 20 of C. All right, and I'm going to add these at the same time. Okay, so when I start adding them is when you can start your stopwatch. And this doesn't work if it's not in front of the white background. All good plans until they're not. how about we try this also? Okay. Let's see if that helps. Okay, here we go. Okay, and ready, set, start your stopwatch. I'm gonna get the next solution ready while you're timing. As soon as you see any sort of color change, stop it. Oh, there we go. So as soon as the color change started, and if you needed to rewind and do it again because you messed up, you can. All right, so that was mixture number 1. So now let's repeat this. I've got a new beaker here. And I'm gonna add 10 mils of B again. And now we're gonna manipulate the concentrations of solution A and solution C. B isn't gonna change. We're only gonna change one at a time. So A, I took 15 milliliters of A and then I added 5 milliliters of water. So that's what's in here now. And then B, I took 20 milliliters still. So this is mixture number 2. All right, same thing. Get your stopwatch ready. All right, set, go. There we go. All right, so this one seemed, I wasn't timing it, seemed to take a little longer. So we diluted A is what we did in that last one. So now let's dilute A more. So we're just making it less concentrated. So I've already added B to this. All right, so now I have 10 milliliters of A and 10 milliliters of water. So it's more dilute, same amount of C. All right, here we go. 1, 2, 3, go. There we go. All right, so it took even longer. So as we dilute A, it seems to take longer and longer for it to happen. All right, so let's do one more dilution of A. By the way, it continues to get darker. Like here's the first one we did, which is already, so that's more of that blue-black that comes after a little while.